Introduction. When an object changes its position with time, it is said to be in motion. Cars, buses, trains, aeroplanes, etc. are the objects that first come to our mind when we talk about motion. However, yet another object has motion. Try to recall a big grandfather clock. Do you remember seeing at the bottom of the clock a long stick with a ball attached? That is a pendulum. It moves back and forth in harmony with the tick-tocks of the second hand. In this lesson, we discuss the simple pendulum, or simply the pendulum. Objectives. At the end of this lesson, you'll be able to describe a simple pendulum, define oscillatory motion and time period of a simple pendulum, differentiate between uniform and non-uniform motion, plot distance time graph. Have you ever observed a wall clock? A simple wall clock or a wristwatch has a circular dial with 3 needles. The circular dial is divided into 12 equal parts, with each division representing 5 minutes. Observe the dial more closely and you will find that it has 60 smaller divisions in it. A single small division represents 1 minute. The longest needle, which moves the fastest, is known as the second hand. It completes 1 revolution in 1 minute. The smallest needle, which is also the slowest, is called the hour hand. It completes 1 revolution in 12 hours. The needle smaller than the second hand and longer than the hour hand is the minute hand. It moves slower than the second hand, but faster than the hour hand. It completes 1 revolution in 1 hour. A simple pendulum consists of a small metallic ball suspended by a thread. The metallic ball is called the bob of the pendulum. The thread by which a bob is suspended is loose at the lower end and is fastened at the top to a stand. When the pendulum is not moving, it is said to be at rest. This position of rest is also known as the mean position or the equilibrium position of the pendulum. Students, let's quickly check what you have learned. Select the correct option and drag it into respective box. Suppose the bob of a simple pendulum is in equilibrium. If we now take it to one side, left or right, and release it, it begins to move to and fro. This to and fro motion of a simple pendulum is called the oscillatory motion. 1 full to and fro motion of the pendulum is called an oscillation. The pendulum completes 1 oscillation when its bob, starting from its equilibrium position O, moves to one extreme position A, from there to the other extreme position B, and then back to O. Alternatively, an oscillation can also be measured as the movement of the bob of a pendulum from one extreme position A to the other extreme position B and back to A. The time taken by the pendulum to complete 1 oscillation is called its time period. You can compute it with the help of this simple exercise. Take a simple pendulum. Let it come to rest. Identify the equilibrium position O on the ground below. Now take the bob to one extreme position A and identify it on the ground below. Start a stopwatch and release the bob at the same time. When the bob comes back to the extreme position A, note the time on the stopwatch. Repeat the activity. This time, start from the equilibrium position O. Note the time taken by the pendulum to complete the 1 complete oscillation from O to A to B, B to O. The time so recorded is the time period of simple pendulum. Motion can be classified as uniform or non-uniform depending on the speed of an object. If the speed of an object moving along a straight line keeps changing, its motion is said to be non-uniform. A bus, for example, moves at varying speeds over varying stretches on its long route. Hence, its motion is non-uniform. If an object moves along a straight line at a constant speed, then it is said to be in uniform motion. A car, for example, may maintain the same speed when it covers a short distance. Motion of objects can be presented in pictorial form with the help of distance-time graph. For this purpose, first draw a horizontal line to represent the x-axis and a vertical line to represent the y-axis and mark them as OX and OY. Measure time along the x-axis and distance along the y-axis. Mark values for the time and the distance on the respective axes. Now plot the points on the graph paper, each pointer presenting a specific combination of distance and time values. Join all the points on the graph to get a linear distance-time graph, which shows that the vehicle is moving at a constant speed. From this graph, we can calculate the distance covered by vehicle at a particular moment. We can calculate the time at a particular distance from the starting point. In the same way, we can calculate speed also. Fill in the blanks with the correct answers. Summary. Let us summarize what we have learned. To and fro motion of simple pendulum is called oscillatory motion. Time taken by simple pendulum to complete one oscillation is called time period of simple pendulum. If an object moves along a straight line at a constant speed, its motion is said to be uniform. If an object moves along a straight line at a speed that keeps changing, its motion is said to be non-uniform. Motion of objects can be presented in pictorial form by their distance-time graph. The distance-time graph for the motion of an object moving with constant speed is a straight line.
Okay, good morning everyone. So this is article 13.3, measurement of time. As you have seen in the video how to measure time and how we were measure timing in ancient timing. So in this article we will learn how to measure time and how our ancients are measuring time at that time they were living. So if you did not have a clock, how would you decide what time of the day it is? Have you ever wondered how our elders could tell the approximate time of the day by just looking at shadows? How do we measure time interval of month a year? Our ancients noticed that many events in nature repeat themselves after a finite interval of time. For example, they found that the sun rises every day in the morning. The time between one sunrise and the next was called a day. तो आज सुबह सनराइज हुआ, वो लेके दूसरे दिन का सनराइज जब तक होगा मतलब वो हो गया पूरा दिन. Some whenever sun comes between, then it means it is noon. When sun set, it is evening, and when moon comes out, that means it is a night. And month was measured from one new moon to the next. A year was fixed as the time taken by the earth to complete one revolution of earth. एक रिवॉल्यूशन जब भी अर्थ कंप्लीट करता है सन के आसपास, उसका मतलब होता है एक साल हो गया. So often we need measure interval of time which are much shorter than a day. So clocks or watches are perhaps the most common measuring devices. So have you ever wondered how clocks and watches measure time? The working of clocks is rather complex. तो जो वॉच है वो कैसे काम करती है वो बहुत कॉम्प्लेक्स मेथड है, सिंपल नहीं है. तो बट ऑल ऑफ देम मेक यूज़ ऑफ सब पीरियोडिक मोशन. आप कभी वॉच को देखना, उसमें हैंड क्लॉक है, सेकेंड हैंड है, फिर मिनट हैंड है, आवर हैंड है, वो सारे जो मोशन है वो सब सर्कुलर मोशन में मूवमेंट करते हैं इन द क्लॉक। अगर आप वॉल के जो क्लॉक है उसके पीछे का ओपन करके देखोगे तो वहाँ पे भी आपको सारे छोटे छोटे व्हील दिखेंगे, वो भी सर्कुलर मोशन में काम करते हैं, वो सब एक दूसरे से कनेक्टेड होते हैं। तो वो जो सर्कुलर मोशन में एक दूसरे से कनेक्टेड होके काम करते हैं, तो वो सारी हो गई हमारे लिए कॉम्प्लेक्स मेथड। तो the working of clocks is rather complex, but all of them make use of some periodic motion. One of the most well-known periodic motion is that a simple pendulum. Okay, now let us see about simple pendulum. Okay, so as you have seen in the figure, there is one rigid stand, one thread and one metallic ball in figure 13.4a. It is called simple pendulum. In 13.4, that pendulum is in rest position. There is no any movement in simple pendulum. But in 13.4, you can see the pendulum is at a different position, and that metallic ball is called bob, and it is in oscillating position. For in 13.4b, it is on first A position, O position and B position. Okay. A simple pendulum consists of a small metallic ball or a piece of a stone suspended from a rigid stand by a thread. A metallic ball is called bob of pendulum. 13.4a shows a pendulum at a rest in mean position. मीन पोजीशन पे मीन पोजीशन पे मतलब रेस्ट कर रहा है। तो व्हेन द बॉब इज ऑफ रिलीज आफ्टर टेकिंग अ साइड स्लाइटली टू वन साइड, अगर एक साइड से आप पुश कर रहे हो तो अभी वो रेस्ट पोजीशन में से मूवमेंट करेगा, मूवमेंट में ऑस्किलेटिंग पोजीशन आएगी। तो the to and fro motion of a simple pendulum is example of a periodic or an oscillatory motion. The pendulum is said to have complete one oscillation when it bobs starting from it means position O, moves to position B, moves to A to B and back to O. अभी यहाँ पे आपको दिख रहा है O पे है, O से वो A पे जाएगा, A को टच A पोजीशन पे जाके फिर से वो B पे जाएगा और B पे जाके फिर से O पे बैक आ रहा है, तो मतलब उसने एक ऑस्किलेशन कंप्लीट किया। अगर वो O से A जा रहा है और E से O आ रहा है, मतलब उसका हाफ ही ऑस्किलेशन कंप्लीट हुआ है। एक ऑस्किलेशन कंप्लीट करने के लिए जो O पोजीशन है, O में से उसको A और A से B और B से O फिर से वापस आना पड़ेगा, तब उसका एक ऑस्किलेशन कंप्लीट होगा। सो अ टाइम टेकन बाय अ सिंपल पेंडुलम टू कंप्लीट वन ऑस्किलेशन इज कॉल्ड टाइम पीरियड। नाउ यू कैन सी एक्टिविटी 13.2. Okay. In activity 13.2, you can see set up a simple pendulum. 13.4, as you can see, with a thread or string of length nearly 1 मीटर। 1 मीटर की लेंथ रखनी है, सारे फैन बंद कर देने। फिर क्या करना है, बॉब को रेस्ट पोजीशन में रखना है। फिर रेस्ट पोजीशन में रखने के बाद उसकी मीन पोजीशन मतलब वो कहाँ पे था वो पोजीशन मार्क करनी है, और उसके बाद उसको फिर वो दीवार पे था वो पोजीशन मार्क करने। ये मार्क करने के बाद आपको क्या करना है, टू मेज़र द टाइम पीरियड ऑफ द पेंडुलम वी विल नीड टू स्टॉप वॉच। अभी टाइम पीरियड हमें उसका मेज़र करना है, तो आप उसको रेस्ट पोजीशन में से मूवमेंट दोगे तो वो फिर से रेस्ट पोजीशन में आने के लिए उसको कितना टाइम लगता है वो हमें स्टॉप वॉच में नहीं तो हमारे रिस्ट वॉच में हम मेज़र कर सकते हैं। तो टू सेट द पेंडुलम इन मोशन, gently hold the bob and move it slightly attached to the bob. It taut while you displace it. Now release the bob from the Now release the bob from its displaced motion. Remember that bob is not a push when it to be released. तो जब वो मीन पोजीशन से दूसरी पोजीशन में गया, अभी उधर से हमें उसको छोड़ना है और उधर से छोड़ के मीन पोजीशन में जब उसको लाना है तो क्या करना है, उसको सिर्फ रिलीज़ करना है, पुश नहीं करना है। हमारे हाथ में जो बॉब हमने पकड़ के रखा है उसको सिर्फ पकड़ा था वो छोड़ना है, उसको धक्का नहीं देना है। तो bob is its mean position instead of the mean position. You may note the time when the bob is at its extreme position. Measure the time its pendulum takes to complete 20 oscillation. Record your observation in table 13.2. The first observation shown is just a sample. Your observation could be different from this. Repeat this activity few times and record your observation. By dividing the time taken for 20 oscillation by 20. So get the time taken for one oscillation. Or the time period of the pendulum. So is the time period of your pendulum nearly the same in all cases? Note that the slight change in the initial displacement does not affect the time period of your pendulum. Nowadays, most clocks or watches have an electric circuit with one or more cells. So these clocks are called quartz clock. The time measured by quartz clock is much more accurate than the watches or by the clocks earlier or we got before. So now units of time and speed. Okay. We know that the basic unit of time is second and its symbol is S. Larger unit of time is minute or hour you can take. So you already know this unit related to one another. So what would be the basic unit of speed? Speed is equal to what? Speed is equal to distance upon time. And what is the basic unit of distance? Basic unit of distance is meter and basic unit of time is second. So speed will be meter upon second. Of course, it such could be expressed in units such as meter per minute, kilometer per hour. Whenever we need kilometer, we will use kilometer per hour, and whenever we need meter per second, we will use meter per second. So you must remember that the symbols of all units are written in singular form. Don't write any unit in a plural form. Kilometer only, not kilometers. Don't use as anywhere. So for example, we will write 50 kilometer, not 50 kilometers. 8 centimeter, not 8 centimeter. So Buzo is wondering the how many seconds there are in a day and how many hours in a year. Can you help him? Go on Google, you will find how many hours in a year and how many seconds are there in a day. So now it is a story of discovery of time period given by Galileo Galilei. He had discovered that pendulum is constant. It is said that once Galileo was sitting in a church. गैलीलियो क्या कर रहा था? चर्च में बैठा था। चर्च में बैठा था और उसने नोटिस किया कि एक लैम्प था, सीलिंग पे लगा हुआ था, उसको चेन से सस्पेंड किया हुआ था और वो क्या कर रहा था? स्लोली एक साइड से दूसरी साइड मूव कर रहा था। तो मूव कर रहा था, तो उसने क्या किया कि एक पर्टिकुलर टाइम पीरियड का टाइम इंटरवल जो था उसमें वो पल्सेस बीट कर रहे थे एक ही सेम नंबर के। तो उसने ये सारे एक्सपेरिमेंट है ना दूसरी चीज़ों पे किए और टाइम पीरियड नोटिस किया कि एक इतने टाइम पीरियड में कितने ऑस्किलेशंस कंप्लीट हो रहे हैं। तो ही फाउंड दैट द पेंडुलम ऑफ गिवन लेंथ takes always same time to complete one oscillation. The observation led to the development of pendulum clocks, winding clock and wristwatch were refinement of the pendulum clocks. Okay. So different unit of time are used depending on the need. For example, it is convenient to express your age in year rather than in days or hours. अगर आपको कोई आपकी एज पूछे कि आप कितने दिन के हो तो वो बताना डिफ़िकल्ट हो जाएगा। आप कितने घंटों के हो तो वो बताना डिफ़िकल्ट हो जाएगा। तो आप क्या करोगे, अपनी एज हमारा जो यूनिट है जो यूज़ करना है वही यूज़ करेंगे कि मैं इतने साल का हूँ। अगर आपको टाइम भी डिस्कवर करना है कि आपके घर से लेके आपके स्कूल तक का कितना टाइम लग रहा है, तो आप सेकंड में नहीं बताओगे, आप मिनट में बताओगे, नहीं तो आवर में बताओगे। फिर आपके घर से लेके आपके स्कूल का डिस्टेंस क्या है, वो डिस्टेंस भी आप क्या करोगे, किलोमीटर में बताओगे, ना तो मीटर में या सेंटीमीटर में बताओगे। तो हमें स्मॉल यूनिट लेना है या लार्ज यूनिट लेना है वो डिपेंड करता है कि हमारी कंडीशन क्या है, सिचुएशन क्या है। सिचुएशन और कंडीशन पे डिपेंड करता है कि हमें कौन सा यूनिट यूज़ करना है। So how small or large is the time interval of 1 second? The time taken by saying aloud 2001 is nearby 1 second. Verify it by counting aloud from 2001 and 2010. The pulse of a normal healthy adult at rest beat about 72 times in minute, that is about 12 times in 10 seconds. This rate may be slightly higher for children. So Paheli wondered how time was measured when pendulum clocks were not available. तो पहले को ये अभी क्वेश्चन है कि जब पेंडुलम अवेलेबल नहीं थे तो लोग टाइम कैसे मेज़र करते थे। तो मैनी टाइम मेजरिंग डिवाइस यूज फॉर डिफरेंट पार्ट ऑफ द वर्ल्ड। sundials, water clock, sand clock are some example of such devices. Different design of this device are developed in different part of the world. Measuring speed.
How was time measured in ancient times? In the beginning, man used the sun clocks to determine time. The oldest sun clock is reported to have been made in Egypt some 3,500 years ago. This sun clock consisted of a stick raised above the ground and a circular dial with markings for hours round it. With the changing positions of the sun in the sky, the length and position of the shadow of the stick falling on the dial would also change. The length of the shadow was divided into 12 hours. Even today such sun clocks are often seen in gardens and parks. The biggest defect of this clock was that this could be of no help in determining time in the night and in cloudy weather. After the sun clock, water clocks were developed. In this type of clock, a fine hole was made in the bottom of a pot and this pot was floated in a vessel full of water. Water used to enter this floating pot through this hole and in a fixed time, the pot would sink in water. These clocks would help in finding time both during the day and the night. Later on, sand clocks were developed. A sand clock consisted of a pot with a hole in the bottom and filled with sand. Another pot would be put under this sand-filled pot. The sand falling into the lower pot would give indications of time. These clocks could not become very popular. The Chinese adopted a peculiar technique to measure time. They would wet a rope, put knots in it at equal distances and light its one end. The time taken by fire to reach from one knot to the other used to serve as units of time. In the year 870, Alfred the Great, the King of England, used a candlestick as a clock. A big candlestick was marked lengthwise and lighted. The rate of its burning would give indications of time. Clocks and watches with moving parts were in use in China in ancient times also, but in Europe they came into use in the 13th century. In 1657–58, Huygens adopted the principle of pendulum in the clocks. Only after this, portable clocks using hairsprings and balance wheels were developed. Clocks of this type are even now in use. In the 18th century, jewels were fitted into the watches. Now clocks and watches run by electricity and nuclear energy are also available. Nuclear clocks have an accuracy of less than 1 second over a period of 300,000 years. Thank you for watching. See you in next episode. Goodbye.